In the preceding example, we assumed that the economy consisted of just two individuals, and we examined how to derive an economy-wide production possibility frontier that reflected the differing production efficiencies of these two individuals. We will now illustrate that it is not very difficult to derive the economy-wide production possibility frontier when there are more than two individuals. So let's start from a point A once again, where we have every individual in the economy allocating all of their time or all of their labor to the production of the good on the vertical axis, that is to say, vegetables. From this point, if we wish to produce some of the good on the horizontal axis, fish, and therefore produce less vegetable, what we should do if we want to be most efficient in our total production in the economy is to use the individual who is most efficient at the production of fish. Once we use all of her time or his time in the production of fish, that is to say, we arrive at the point B, then in order to produce more fish, we would use the individual who is the second most productive person in the economy to produce fish. And so their production possibility frontier, their individual production possibility frontier, is going to have a different slope from the first individual. But when we use the second individual, we do get more fish as a result of reallocating that person's time away from vegetable and towards fish. We don't get quite as much fish for every unit of vegetable less that the second individual produces compared to the first person, and the slope of the segment BC indicates the additional amount of fish that will be made available as a result of producing less vegetables. Continuing with the same logic, once we reach the point C, we have exhausted all of the labor available to the second individual, and we start to use the productive capability of the third individual, and that third individual's production possibilities are represented by the segment CD. And for the last individual, assuming there are just 4 individuals in the economy, if we have used all of the labor available to the first 3 individuals, then we finally bring into play the person who is least productive at producing fish, in the sense that if we reduce their vegetable production by a certain amount, their output of fish will be less than the output of fish of individuals 1 through 3. So this is the economy-wide production possibility frontier in the case where we have 4 individuals. Frequently, we, rather than drawing a production possibility frontier for the economy with a whole series of individual linear segments, we just draw a smooth, curved shape to represent those economy-wide production possibilities. So, to summarize to this point, the production possibility frontier for the whole economy is obtained by allocating productive resources most efficiently. And this is important. When we start from the point A, we want to use the person who is most efficient in the production of fish. Then we use the person who is the second most productive, and so forth. What is the opportunity cost of producing more fish? The opportunity cost of producing more fish is the amount of vegetable that we have to give up. And it's very obvious that as we move from point A to B to C to D to E, that the amount of vegetable we have to give up to get a given additional amount of fish becomes larger and larger. So what we can say is that the opportunity cost in the economy of producing more fish, given that it is the amount of vegetable that we must give up, the opportunity cost in the economy of producing more fish becomes larger and larger. The opportunity cost of producing more fish depends upon exactly where we are on the production possibility frontier. The shape we give to this economy-wide production possibility frontier, or the word we give to it, is to say that it is concave in shape, and it is made up of the envelopes. It is made up or it is the envelope of all of the individual capabilities. So when we draw a production possibility frontier for the whole economy, we frequently see it portrayed as by this concave line ABCD that we have here. Before leaving this development of the economy-wide production possibility frontier, it is useful to look at it in a little more detail from the standpoint of understanding what we mean by opportunity cost. So let's head this by writing opportunity cost. Specifically, we said a few moments ago that the opportunity cost of producing more fish depends upon exactly where we are on the production possibility frontier. So let's just illustrate this very quickly. Suppose we are at the point A, where all of the economy's resources are being devoted to the production of vegetables. And we assume that we want to produce a given increment in fish. That line distance represents a given number of units of fish, and we want to produce this additional amount of fish. What is the cost of doing that? What is the opportunity cost of it? Well, it is obviously the amount of vegetable that we must sacrifice in order to produce that additional amount of fish. So let's go up to this is meant to be a straight line, let's go up to the production possibility frontier up here. And we are now on the production possibility frontier for the whole economy, but the slope of this segment of the economy-wide production possibility frontier is reflected, or reflects rather, the production capabilities of the person who is most efficient at producing fish. So when we begin to produce fish from this point A, and we want to produce this positive increment in fish measured along the horizontal axis, our diagram tells us that what we must do is to give up a small amount of vegetable here, denoted by the distance from the point A down to this point here. So the amount of vegetable we give up in order to obtain this additional specified amount of fish is relatively small when we are on this segment of the economy-wide production possibility frontier. Let's look at the opportunity cost of producing fish when we are at a different segment, when we are on a different segment of the production possibility frontier. Let's suppose we are at the point C here, and we wish to go from producing that output of fish to a larger output of fish. But once again, the increment in the amount of fish that we want produced in the economy is going to be the same as in the first case. So this distance here. So let's plug in this amount here, and this represents the extra amount of fish we want, and let's draw a line up to the production possibility frontier here. Well, since we are starting at the point C here, this is where we are starting, and we want to produce this increment in the amount of fish in the economy. How much vegetable do we have to give up? Well, we're going to go from point C to this point here on the production possibility frontier, and consequently we will be required to give up that amount of vegetable. So we'll have a negative V in order to get this positive amount of fish down here. Well, it's quite obvious that when we are at point C, we have to give up more vegetable in the production of this additional amount of fish than we had to give up at A. That is to say, the opportunity cost at the point C of producing more fish, it differs from the opportunity cost at point A in producing more fish. And in fact, when we move from one segment of the production possibility frontier to another on the economy-wide production possibility frontier, the opportunity cost changes all of the time. So this is what we mean by saying that the opportunity cost in this economy of producing an additional amount of fish depends exactly where we are on the production possibility frontier for the whole economy, and exactly how much vegetable and fish we are producing at the point where we start.